Let's get started. So my name is Christos Anagnostakis. I'm a freelance enterprise architect, strong technical experience for over 20 years, facing the GDPR challenges since late 2013. You can see my soft spots here, but that is not the important stuff. Let's get going with the presentation. So the agenda: an introduction, the problem to solve, the lawful ground in Pulsar, consent in Pulsar, please forget me, and then a Q&A. So let's start with a quick introduction. What is the problem? What was life before GDPR? So what you're looking at this picture here is actually history, at least in Europe. So I took as an example a test drive application. So on the left side, you have some data that represent a data structure that you would use to track a test drive for a prospect to buy Tesla in this case. You're using a topic to store this information in the Pulsar broker. And then on the right side, you have two applications that are consuming in your organization. So the upper one, the test drive application, is the application that is serving the use case of the test drive use case. The one in the bottom, the direct marketing application, sneaked in to sell cars. So this is a very real situation, and you probably have faced it also in your environment. How complex is your environment? Is 10 times this, 50 times, 100 times? So one day you wake up and somebody says, these are personal data. You cannot touch them. Welcome to GDPR. So what does GDPR say? Stay away from personal data unless you have lawful ground, like, for example, a contract, the data owner's consent, a legitimate interest. Of course, GDPR says also, we realize that we make your life difficult. So here is a hint. Use privacy by design. So this is basically the subject of this talk. So let's find out what is privacy by design. So in the picture on the left, you will see what privacy by design is not. So privacy by design means be proactive rather than reactive. So it means anticipate and prevent privacy invasive events before they happen. Data protection is best adhered to when it is already integrated into the system from the start. So these last words are underlined and in bold because we're going to talk about exactly that. So what is the problem to solve? Let's take a look at this picture. We just need to find out about the yellow things, the orange things, the two filters. Here we have someone's data, someone's personal data. Here we have what an organization policies allow to access in a given context. So we need to put these things together so that we filter the personal data so that the outcome is really the data, the personal data that we can access. That might not be enough. Maybe we need also to obtain consent from the owner of the data and filter the data further so that we find out what an application within the organization can access. So the first filter is about lawful ground that we talked before. The second filter is about the consent. So what about our apps? Well, the test drive app has a lawful ground. When the customer walked in and said, I want to test drive this car, we said, that's okay, but we have to give you have to give us your data. We have to use them for the duration of this relationship, from start of the test drive to the end of the test drive. And that is okay, so no problem with that. This is not the case with the second one, the direct marketing app. So there, we need to have the consent, which we don't. So this is a no-go. How Pulsar can help us build privacy into our architecture? Let's check about lawful ground first. So lawful ground will be, let's find the first filter. The basic question is, can Pulsar deliver this? So what we have in this picture, test drive application gets all the data, direct marketing application does not get the personal data because it doesn't have consent. We need 4 things. First, we need to identify personal data within a message in a non-ambiguous manner. The second thing is to provide Pulsar a way to find them. The third thing is provide Pulsar a way to find out which are authorized to access, and then apply the filter. Let's start from number 1. You see the right bubble, the reddish one, contains all the personal data used within the organization. The bubble on the left is the message attribute. So you have a message in a topic that contains some personal data. You want to find actually those. Oops. Okay. Sorry about that. So, but we know the personal data, it's those. Well, yes, in this message, but different teams might use different names for the same data. We need to do something about that. Let's create a non-ambiguous reference to the personal data. If we add some metadata to this data, then we have a better chance of identifying them in a non-ambiguous manner. So let's introduce a scope that is personal and a scope name. For example, in this case, first name. So now we got a non-ambiguous reference to the data, but we have to go to the second step now. We identify this data, we know them, first name, family name, and email. We have to explain Pulsar where to find the data. So why don't we put them in the schema? If you see this example, the Avro schema, in the field definition, in the appropriate place, we can include the metadata. And Pulsar can have a look into the schema and find out the metadata, which means that Pulsar can find it very easily what are the attributes that correspond to personal data that are contained in the message. So now we have those. We know what are the personal data in the message. Let's do something about that one. Which ones can we access? We already have the possibility to consume the topic. So our role says consume topic T. This we get from Pulsar out of the box. Wouldn't it be convenient to have something like this? So have some additional attributes in our role that say you can read these 3 attributes from the message. If Pulsar can provide this out of the box, we are basically done. So let's imagine the Pulsar manager reading the schema to find out what are the personal data and allow us graphically to create the role that we see on the right side and store it with together with the other role or role data in the appropriate backend. We can imagine to go even further. We can imagine another system like, for example, a data catalog system, creating the schema and using the RESTful endpoints available in Pulsar to put them in the right place. And on the other side, also create the appropriate roles, again using RESTful endpoints that are available in Pulsar. So we got this as well now. The only thing left is actually apply the filter. So the filter would look something like that. We take someone's personal data and we subtract the intersection of its personal data with the data that the organization policies allow to access in the given context. Which means that as soon as we find them, we null their values and we obtain the result that we are expecting. So to apply legal ground in Pulsar, we will need to earmark the personal data using the Pulsar manager or the RESTful endpoints available in the Pulsar. Then we will need to configure the appropriate roles using the Pulsar manager again or the RESTful endpoints available in Pulsar. And then let the Pulsar broker do the rest. And there is one last thing. If we forget about GDPR, this first filter that we have constructed help us get some real data governance on our data. Sorry, I have some consent. So now let's talk about the consent. So we need to find a solution for this guy. The direct marketing guys are not very happy. We need to support them. So it means that we start to take into account the owner's consent to access the data. We need to do three things. We need to store the consent, we need to access the consent, and we need to filter based on the consent. So, store the consent. This picture here gives us an example of what we could store. It's not a detailed definition of how to store the consent. So on the left side, we will see that we have, say, a prospect ID in a specific context and some personal data that he gives the authorization to access. This is not the only thing that we need, though. On the right hand, you'll see that we need some information to be able to prove that the owner of the data knows what data will be processed and how. We also need to prove to store some proof that the consent was captured by a well-defined process. For example, a session ID, if it was captured. How do we store them? Well, let's store the consent and the associated additional info in a Pulsar topic. So in time T1, we store some consent, and in time T2, later than T1, our user says, no, you don't have consent anymore. So all this is gathered in an immutable log of the consent, and we have the history for free. Access the consent. When we are talking about accessing the consent, we are having many different cases. We are mostly interested in reading the latest consent value. That is for everyday use when we want to apply the consent. In the case of audit, we need the detailed history. Now, Pulsar helps a lot this situation because it gives us topic compaction, and we just have to use the read compacted attribute. So we can, for example, read the consent topic in an ELK stack. If we set the read compacted equals to true, we get the latest value. If we set the read compacted equals to false, we get the consent history for auditing purposes. Now it's time to filter based on the consent. So let's imagine a topic on the left which contains some personal attributes, personal information, and a consumer or a reader that wants to use this data. How we can introduce the consent in this situation? So imagine a Flink queryable state that is created by reading the consent topic with compacted equals to true. Our application, consumer, or reader can now check the consent in the queryable state and apply it before it delivers the information of the message to the application. So we set up the consent information in queryable form, but we're not done, because here we are exposed to accidental source code changes. A developer in the application might do something wrong, and the personal information can leak. So ensure reliable filtering for the forbidden values is a bit reddish. It cannot be green. We have a problem to solve. Let's try something else. If we have a consumer or a reader that knows how to do this, so that knows how to read the queryable state and the topic, and can already filter the data that we shouldn't see, but they live somewhere in the Pulsar library and not in our application, in our organization, we are much safer. So now we have still up-to-date information in queryable form, but we ensure reliable filtering of the forbidden values. We can simply extend this into our application and do whatever we want. So to apply the consent, we need to configure appropriately the Flink queryable state and the consumer or reader, to extend the consumer or reader to perform the desired processing. Then about rinse and repeat, because this is something that we can do as many times as we want. We can reuse the same Flink queryable state, etc. Now, another important part, please forget me. So what happens here is the owner of the data comes and say, sorry, I don't want you to use my data anymore. Forget me. What does forget me mean? It means put the personal data beyond use as soon as you receive the data owner's request. In a second phase, it means delete the personal data as soon as your legal team says so. So let's start to put the data beyond use. We could use the same approach. We could use a Flink queryable state to read the forget me topic, in which we register the appropriate information to know who does want his data to be viewed anymore. So if our consumer or reader consults this queryable state, then he can take the decision to actually remove the data from the messages in the topic. And when we are extending and consuming, we get to see the data that we are about to see. So this has immediate effect. The moment that the forget me topic receives some information, it is applied automatically to the next values, the next messages that the consumer or the reader is going to treat. So the consumer or reader checks the existence of the prospect ID. If it finds it, it reads all the values of the attributes representing personal data in the message, and we're done. Let's apply it in the case of the consent. We will take the previous picture and we'll enhance it a bit. So we're not only going to ingest the consent in the Flink queryable state, but also the forget me topic. And our consumer or reader is going to check two things. So it checks the existence of the prospect ID. If it finds it, it applies the consent, like before. If it doesn't find it, it mutes the values of the attributes representing personal data in the message. And then we can consume without fear. Delete. Delete is a bit trickier. There are several ways to delete the data when the legal department says it's okay to do so. For example, you could post an empty message and compact the topic will sort of delete the data if topic compaction makes sense for the data and the topic, and read compacted is true. But this topic is too short to talk about this. We will probably have the opportunity to talk about this part in a future presentation. So thank you very much for your attention. So if there are any questions.